Plastic pollution generally is associated with the marine environment. So all of us have a picture of a plastic bottle or maybe a plastic bag in the ocean. As this plastic bottle or plastic bag stays in the ocean for a long time, they start to break down into smaller particles. Sometimes these smaller particles are so tiny that 1/10 or 100th size of a salt grain. So if they're so small, through the process of wave breaking, they may be basically ejected to the air.
So when waves break in the ocean, air gets entrained into the water and these bubbles rise up, they burst, they emit particles, the organic matters, bacteria, viruses, whatever's in the water, into the atmosphere. And we're specifically looking into the transfer of microplastics by these bubble burstings. What we do is basically simply put known size of microplastic particles in the water, and we do the wave breaking replication phenomenon in the tank, and we collect whatever gets in the air into a filter sample, and we scan that and see the distribution, relative distribution of particles in the water and in the air. That way we know if they can get airborne or in what ratio can they get airborne.
These tiny particles, when you scale up to the size of the ocean, we're talking about tons of plastics getting to the air. Recently, microplastics have been found in lung of human beings, so it shows that inhalation is a pathway for the plastics to get into the body. Also, they've been found in blood. So my lab looks into this process and trying to understand the mechanism of this aerosolization and how they get to the air. And once they're in the air, how long of a distance they go after being air. I think it's really important and makes me feel good that what we are doing in the lab is actually have impact on people.